And we are recording. So I just want to say thanks everyone for joining us for this month's St. Louis.NET Meetup. So we're going to jump into Jeffrey's talk here shortly. I just want to share a couple announcements about the meetup itself. Next month, we will have a talk from Kevin at Architect Now regarding a case study with Power Apps primarily. So that's going to be a pretty good one to catch. And that is probably going to be our last 100% remote meetup. We're currently planning a lot of different things, actually. For the month of July, we're going to have, if everything goes well, we're going to have a social event. So instead of a presentation, we might have a panel out somewhere, kind of like what we do for our holiday parties. And so, yeah, watch Meetup for that. We'll have more next month on exactly where that will be. And for August, that should be our first in-person meetup. We might do a hybrid as well to where we'll broadcast possibly over Teams. But nonetheless, we are shooting for having these meetups to be back in person and possibly still keep them hybrid and record them as well. And we might have a new home for the St. Louis.NET Meetup. So more details to come there. And that is all I have. So I want to mention that Build starts tomorrow. So if you haven't, I threw in the chat a link to Microsoft Build. It's a great event to check out with a bunch of content. So I recommend registering for that. And that is all I have. So Jeffrey, I am going to turn it over to you. We're going to jump right into this. This is going to be a great talk. I can see just by the title.
Awesome. Well, fantastic. Thank you so much for having me.
And I will monitor the chat for you. And we will, Jeffrey might catch some of these questions through the chat, or if you jump in right away with a question. But nonetheless, we'll spend some time for Q&A at the end and look at the chat.
Yes, and I'll try to work in what I can see directly during it. But yeah, if there's anything that's missed, then we'll round them up at the end. It'd be great.
All right, all yours.
All right. So thank you very much for having me. It's great speaking to another group in the good old Central Time Zone. I live just about an hour west of Austin, Texas, here in the middle of Texas, and it's fun. Now today we are going to be talking about DevOps, and we're going to be talking about .NET, and we're going to be talking about targeting Azure. And the goal for this talk is that as you improve the DevOps environment for your own software systems, that you have some rules of thumb so that so even if you fall down, you fall into the pit of success, or you fall forward, as opposed to falling on your face or falling backwards. And I appreciate you spending your evening here. I know just from experience that if you're coming to these types of user groups, if you're taking your own time in the evening and tuning in for these types of things, and that probably means that you're the type of person that wants to get more done, you want to move faster, you want to produce higher quality, so that you can deliver for your team and your company and your customers, and that you care about delivering well. And so all of you are in good company with each other. Let me just tell you a little bit about myself. I do a lot of speaking, but I'm not sure that I've ever spoken with this group before. And so that's me holding my hand out to the Longhorn Cow. That's one of the ones that kind of roam around our property here in Texas. We graze the neighbors' cows. They like to eat molasses treats right out of your hand. Top right, that's me in the dirt bike race. Actually, I'm sore right now because this past Saturday there was another dirt bike race, and it's enduro style, kind of like hare scramble, where it's a 60-minute plus 1 lap race. So it's nonstop, going as hard as you can for a full hour. And I'm not particularly good. That's why I'm kind of buried in the pack, but it's fun nonetheless. And my middle son, he likes to do it as well. That's his picture, kind of fixing a flat. And then I have a 13-year-old daughter who likes to do it more casually. She doesn't do every race. And then I have an 8-year-old daughter as well that is probably into it even more than my son. and she rides a Yamaha 110. So we kind of go out camping and spend one weekend a month out on the race course. So that's fun. That's what we do for fun. All right. So in today's session, we're going to define the challenge that is DevOps, and we're going to look at the structure for a DevOps pipeline and talk about the distinct parts to it. And pretty much, and I'm going to make a 80 to 90% statement here. Pretty much every software system that you're going to build in a business setting is going to have this structure of a DevOps pipeline. So even if I say some things and you think, oh, this really doesn't apply to my situation, just take the concepts and take the order of events, and I'm 80 to 90% sure that it's going to apply to your situation, and the exceptions are going to be more kind of outliers or more minor points. And then we'll talk about what to do to get started. And so there's 7 key stages of the pipeline structure, and we'll dig into that. Now, what's every good author kind of gives stuff away for free. So I wrote a book not long ago called .NET DevOps for Azure, and you can get it at apress.com or Amazon, wherever books are sold, for a hard copy. But if you are good with digital, if you want a digital copy, I've got a deal with the publisher. I can send out individual copies. If you will send me an email, then I will send you a digital copy of .NET DevOps for Azure. And if you already have the book, you'll probably recognize some of these diagrams, because the book kind of goes through a lot of this stuff as well. And over my career, I think I tallied it up once. I've advised and helped over 100,000 professionals across over 40 countries to be better at software, and through the book, through speaking things like this, and even through work, is kind of what I do for work, and through the podcast, the Azure DevOps podcast. I've kind of been able to help a lot of people, and helping people is fun. So you might be interested in the podcast, Azure DevOps. And also, there's a new video podcast that I launched. It's just getting started, but if you just search for Architect Tips, then you may be interested in taking a look. The thing of Architect Tips is if you send an email into the show with a question, then we may choose that particular question to be the topic of another Architect Tip video, which is maybe around 5 or 7 minute clips. All right, so why don't we dig into the 7 key elements of a DevOps environment? And they're right here on the screen. There are things that you do before you put your hands on the keyboard to figure out what you're going to do, how you're going to design things. Then we arrange certain things in our version control system. Then we have different activities in our build. And after that, we do some full system testing, which is different from unit testing. Then we do user experience or manual testing. Then we do a production release, and then we observe how the software system is working in production to make sure it's doing what we expect it to do. All right. Now, I like the term pipeline because it conjures up the right imagery of water. Water is the perfect, it really is the perfect analogy to what we want from effectively a software engineering environment, an environment that is meant to ship software. And so I like that. I like the imagery that a pipeline conjures up. Now, if you think about it, if you turn on the faucet in your sink, you expect water to come out. If water doesn't come out, there's a problem. If the water doesn't come out when you want it, there's a problem. At the same time, if you turn on the faucet and it just blasts you like a fire hose, super high pressure, well, that's a problem too. And if you turn it on and then some comes out and then it stops, and then some more comes out and then it stops, that's a problem. You want it to always be there, always be reliable. At the same time, you want it to be clear, clean water. If you turn it on and it's brown, that's a problem. If it's yellow, that's a problem. If clumps of dirt glug, glug, glug out of the pipe, that's a problem. And at the same time, we all know that the water needs to be clean in every section of the pipe, from your sink to the walls, to the foundation, out of the building, down the street. Every section of the pipe needs to have clean water in it, because there's no way that you can have a, John, I'm wondering if is that John or somebody else is not muted? I'm not sure who it is. I can't tell because I'm not an admin on the Teams.
I got it.
Cool. We want the water in every section of the pipe to be clean, because there's no way that we could have a massive Uber water filter right at the kitchen sink, expecting to have brown, dirty water everywhere in the pipe, and then somehow filter out all of the impurities right there at the end before the water comes out of the faucet. That's just not going to work. All right, so take those parallels and transition it to what we expect out of a software delivery system, which is effectively what DevOps helps with. It helps us deliver software better. And so there's two concepts there that water helps us with. There's the concept of flow, and then there's the concept of quality, which DevOps is calling feedback. The original creators of the term DevOps talked about the three ways of DevOps: flow, feedback, and continuous improvement. And the second one, feedback, was all about quality gates and information radiators, where you know if you introduced a problem so that you could fix it immediately and keep it high quality. So we want flow, we want throughput. We want the software change or the software feature to always be ready for our customer when they are ready for it. We want to move at the speed of business. We don't want our companies or our customers to be ready for the feature and then they say, oh, we have to wait on development. Yep, still waiting on development. Gotta wait on development. We want that feature to be ready for them. We want it to be done. We want it to be sitting right there ready to go to production, so that they can just decide, yep, okay, now let's ship it. Let's get it out to production. And so it's a problem if they're waiting on us. At the same time, it's a problem if we push out software features before they're ready. And then it's also a problem if we're starting. Now, Scrum has told us that, hey, we need to go in month-long or every 2-week chunks rather than once a quarter or twice a year. And that was a good improvement from what is now 20 years ago, when software projects used to have releases once every 4, 6, 9 months. So it was definitely an improvement from there. But people in the industry have learned that, you know what? The concept of a sprint boundary, once you have DevOps automation in place and the engineering principles that go with DevOps, the concept of a sprint boundary becomes less important. And a lot of people have gone to weekly sprints, and then they've gone to just dropping the concept of a sprint altogether, because they realize that, you know what, we don't need sprint planning, because we can talk about something in the morning and then it can be shipped off to production by the end of the day, or at a minimum shipped off to a manual test environment so somebody in the organization can validate it and maybe get it to production tomorrow. And certainly companies around the country and around the world are demonstrating that code can be written and in production in the next hour if the process is put in right. So we obviously need the right process, but we need the engineering practices that go with this to enable us. And so that's what this talk is about. Quality is the other element of the pipeline. And I'm going to talk about how every step of the way is a checkpoint. Every time we move software forward down the DevOps pipeline, there also needs to be a mechanism of feedback. So if we introduce something destabilizing into the software, our DevOps environment catches it for us so that we get alerted pretty much right away. Because if you get alerted within minutes of making a mistake, you have all that information in your head and you correct it really easily. If you don't know that you made a mistake until the next day, or maybe the day after that, well, then you have to go and reverse engineer and you're not quite sure what you were working on. All right, this is the top third of a DevOps architecture poster. And just very quickly, I'll show you what the full poster looks like. I know you can't read any of the text, but I'll go back to the top third. And it's a highly shrunken technical blueprint for the structure and flow of a pipeline implemented with Azure DevOps Services and Octopus Deploy and Redgate SQL change automation. It's got continuous integration. It's got a 3-tier deployment pipeline. If you're interested, I'd be happy to send this to each of you. If you just send me an email, I'll give you the high resolution PDF of it. It's meant to be printed 2 feet wide and 3 foot tall, but it kind of outlines in detail all of the things in what order you need in your DevOps pipeline and all the steps that complete it. And I'll just go over the high level things in the scenarios box. Every pipeline needs a private build, a continuous integration build, static code analysis, release candidate packaging, environment configuration, your deployment, your startup smoke tests, your automated full system tests, and approval button for a production deployment, and then DevOps diagnostic and monitoring. Now, let me just touch on something that is unfortunately, starting to become a epidemic, and that is people who are saying we have continuous integration in place, or they'll say, oh yeah, we've got CI in place, but we don't have CD. Well, let's dissect what continuous integration is, because those get confused, and continuous delivery is starting to be used as automated deployment. Very few companies actually even need continuous delivery. Most companies will be perfectly happy if there is an approval button on production. They don't need to continuously deliver to production like Facebook or those companies that the developers just do something and then get it in production a few hours later. Small, tiny little tweaks. Okay, most people have some type of product management and some type of looking each other in the eye and say, hey, are we ready to go to production? And now if you can do that every day, every other day, you know what? That most of the time that's fast enough for a lot of organizations. Now let me talk about continuous integration. There are 3 key phases to continuous integration. And the first phase is the private build, which happens on a developer's workstation. The second is the integration build that happens on a shared build server. And in this case, most likely it'll be in Azure pipelines. Now, I really don't care if you're using TeamCity or any other build server. At this point, there's so many good build servers out there. It's fine. Integration build, I'll come back to it. And then you need a deployment and full system test run. Those are 3 phases: private build, integration build, first deployment. Okay. A lot of people are triggering an automated compilation process on Azure pipelines and then saying, all right, we now have CI in place, but they only have 1/3 of CI in place. So the private build, each of these phases has a question that it answers, and they all have a purpose. And obviously the steps in each of them are going to be dependent on your architecture. If you have an architecture where it's some flavor of ASP.NET, like you have ASP.NET Blazor for a web application, and then you have SQL Server database, and that's all your database is, then you have 2 things that you need to worry about: the database and your Blazor application. And so in the private build, you're going to need to set up your environment, which is your database schema, and then you're going to need to run some test suites, which you'll have unit test suite, you'll have a component level integration test suite so that you know that your application can call database queries and such. And then you'll probably have some unit tests for the Blazor components using the bunit library, and that's all great. And it's pretty simple because you only have 2 deployed components for that application. But the private build, what that does for you is it tells you you have not screwed up anything. It tells you you are still safe to share this code with, you're still safe to push the code up to the team's Git server, all right, your version control system. It'll also tell you if you broke something and you've destabilized the code base and it's a total waste of time to upload or to push your commit, all right? Now, let's talk about the integration build. The integration build answers the question, does your feature branch combined with all the changes that your team is currently making, does that still work? Or is something broken and do you have a destabilizing factor? Now, if it's all good, if it builds, well, then you're good to do a pull request and your teammates can check out your changes based on the team checklist and merge it into master. And then the build's going to run on master. That's integration build times 2 because we can run the integration build on multiple branches. And then that will produce a release candidate, a deployable release candidate with a name and a version. You'll have 2 packages, one for the website, one for your SQL Server database. Then we get to the 3rd stage of continuous integration, which is the first deployment. And we're going to deploy that database to our TDD environment. That's our test automation environment. And we're going to deploy that website. And then we're going to start it up. And then we're going to run our full system test suite. And those tests are typically acceptance tests. They are full scenario. And those tests have to be run against a fully deployed and operational instance of the full application. And if it's a web application, of course, you're going to be using Selenium to drive a web browser and poke in text boxes and buttons and all that stuff. And that answers the question, does this release candidate still deploy properly, still start up properly, and still work, still do all the things that it used to do? And if it's yes, then that's great. We can deploy it to a manual test environment so that a person can then check things out and run it through its paces. If anything fails in this stage, well, that release candidate is toast. It's garbage. It should never see the light of day. There's no point in deploying it to a manual test environment because we're just going to waste somebody's time. And we need to figure out how the integration build passed, the private build passed, the integration build passed, and now for some reason it can't deploy. And it's probably some environment configuration, or it could be some bit of functionality that was not tested by our integration test or unit tests, and we need to fill in a gap of testing and, of course, and fix the bug. So continuous integration has those 3 key phases, and if you're interested in the original book called Continuous Integration, it came out in 2006, and it defined what continuous integration was. Now, let's carry on further down. And by the way, DevOps kind of took these engineering practices that started with the extreme programming methodology that first came out in 1999. It was kind of developed in the late 90s, but then there was a book called XP Explained by Kent Beck in 1999. And of course, the Agile Manifesto came out in 2001, and then Scrum and Kanban and the Agile movement. And I realized that probably for half the people in this user group, that was before you came into the industry, but it's just some of the history. And so continuous integration as a practice came from the extreme programming movement. And then there was books written about it, and a lot of people have talked about it. And now the tooling is so much better than it was back in that time, where we can trigger builds off of changes in source control so easy, but we still need to put the appropriate steps in place so that we can have the automation work for us instead of it not really catching things. We want, every time we push code forward, remember, every time we push code forward, we want a corresponding check. We want a filter, a figurative filter in our pipeline to catch impurities, to catch mistakes. We are going to screw up that code. I've been coding since 1997, and I still introduce defects into the code. However, I know at this point in my career to work within an environment that very, very quickly catches my mistakes. So it appears to people downstream that I don't make mistakes, which is not true. It's just the environment catches mistakes so much more quickly that we don't ship mistakes. And that's the thing. You don't want to ship the mistakes to the customers. You want to find them really, really quickly, because when you find them quickly, you can fix them quickly. Now, after we have a release candidate, we need to deploy. Now, every application needs a minimum of 3 environments. That is the minimum for doing DevOps, and I'll tell you why. There are 3 distinct types of environments, and you need at least one of each. So there's 3 distinct types of environments. Everybody knows production, and you need at least one of those. Now, a lot of software systems has more than one production environment. Heck, Microsoft Azure has more than one production environment. Every Azure region is a production environment, and you choose which one you want to be in. And of course, every region of Azure is clustered. In other words, there's 2 physical buildings, 2 physical data centers at a minimum that make up each Azure region, so that there's fault tolerance. So, think of multiple production environments, and then for each production environment, they run it in a clustered fashion. And that's why for each data center there, you don't have to pick the data center within the region. You just pick the region, and then Azure kind of figures out which data center to put your stuff in. Backing off from production, we have the manual test environment. And of course, you need an environment where people can run your software and check things out. And if it's behaving the way it should, then we push it forward. If we find a problem, that release candidate dies and we put in a bug. Now, there's a lot of reasons to have multiple manual test environments. And a lot of companies do. And common names for manual test environments are dev, test, sit, dit, staging, UAT, all kinds of names. But this is the environment type that is meant for somebody to open up the software, use it, and just look with their own eyeballs what it's doing. And maybe different departments might need their own dedicated manual test environment, but that's the environment type. It is a manual test environment. You need at least one. Okay. Now, pull back from that, and the first environment that we need is the test automation environment. We tend to call that environment the TDD environment to invoke the concept of test-driven development and to give it a 3-letter acronym. But it's the test automation environment. No humans are really allowed in that environment. There would be no point, because we're constantly reconfiguring that environment, deploying the latest release candidate, running our full system test suite, and then blowing the environment away. It would be pointless for a human to touch that environment, because it really is just meant for automation. It's meant to capture our 3rd stage of continuous integration to make sure that that release candidate that was just packaged is even worthy to go to a manual test environment. Okay, so that is the high points, and then I'll come back to telemetry. All right, let's talk about the process as a whole. There are 12 different stages in what you would put forth as a Kanban board. If you were to unravel these and put columns on a Kanban board, these would be the general stages. Now, the top 4 are things that we need to think about and decisions that we need to make even before we put our hands on the keyboard. The middle 4 are massaging the code, getting the code right, and the bottom 4 are deploying the application and verifying that the application is ready for deploying, and then monitoring it as customers are actually using it. So let's go to the top 4. Conceptual definition, user experience design, technical design, acceptance criteria, and test design. Notice that these are all decision type words. Now, by the way, I don't care what you call these stages, rename them, but you need to have the concept of them represented in your process. The first one, conceptual definition, that's the beginning of requirements analysis. That is figuring out what the heck we want to do, what our goals are, okay? And after we figure out what a business goal is, then we start talking about user experience design, which is basically saying, okay, here's the goal. I need to modify the software so that this starts happening. And then you start thinking, how am I going to make that happen? If there's visual elements, then of course we'll start doing some wireframes with pencil, and we'll think, okay, well, we might need a screen that has some certain elements on it, and a user may click this button, or a user may pull a smartphone app out of their pocket or do something, and we figure out how a person would interact with the software so that the software can do something that accomplishes the goal that we decided in the conceptual definition. Now, even if the feature doesn't really have any visual elements, there is always a user experience. For example, even with a backend job, if refreshed data needs to go from system A to system B within 5 minutes, that is a user experience. And if the data takes 5 hours to get to system B, that would not be a good user experience. So regardless if it's visual or something else, there's always a user experience. How is a person going to know or experience that the software is behaving appropriately? Next one is technical design. And that we ask the question, okay, with how this is supposed to work, is the current architecture sufficient to make it happen? Or do we need to discover some new architectural elements that need to be present? Or are the current design patterns appropriate for any of the developers on my team to put this design in place? Or do we need a new prototype or first implementation of a new pattern for this new feature? Okay, make those decisions there. Are there any new libraries or Nuget packages that need to be prototyped and proven and pulled into the application because they're necessary? For example, if the user experience was the first time you processed payments with PayPal or another merchant, well, you would for sure introduce a new architectural element, you would pull in a new library, and all of those things need to be vetted. Because if you just made some assumptions that, oh, such and such pattern is appropriate, and we're going to pull in library A, and then you just write that down and then move it forward, well, that's an assumption. Maybe that'll work, maybe it won't. So you need to really be sure about those things in that. And technical design, that's where your lead engineer, your architect, that's where they write code. Most of the code they write, no, I'm not talking about 2 or 3 person teams where your architect is also a full-time developer. If you have more developers, then you'll probably have designated one person to be, the lead and the technical design column on your Kanban board. That's where they write code, prototype code to flesh out new patterns. All right. Then the next one is your test design. And that is where the concept, the definition of done, or what it means to have acceptance criteria, what it means to be complete. And so you think about the user experience you're going for, and what are all the pathways through that? There always tends to be a happy path and then an exception path. So you always tend to have 2 test scenarios. And I'm not talking about test cases, because really when we talk about test scenarios, you could just bullet point them out. They could be, 3 to 5 words in a bullet list. And you have scenario 1, oh, run it through like this. And then scenario 2, oh, run it through like that. And of course, you run it through like that, and we expect it to work. We run it through like that, we expect it to throw an error message, things like that. So you need to have all the different scenarios that this new software behavior needs to cover defined in just a simple bullet list so that the developers know when they're done. And then in the middle, of course, we write code, we do our private build process like we talked about, our integration build process, and then we start deploying things. But I wanted to harp on the top 4 design decisions, because if you move through and don't make those 4 design decisions, it really doesn't matter what you're doing from an automation perspective. You're not going to have a fast process. If you put garbage directions into developers, then they're going to be sitting with hands on the keyboard thinking they're ready to do something, and then they realize, oh shoot, what should I do here? And developer A is going to make certain assumptions that are different from developer B, and maybe developer C is very good at stopping and asking questions, and developer D is not. They just kind of plow forward with, oh, it must be this way, and then you just generate you either generate blocking issues or you generate rework. if you decide not to make these 4 types of design decisions before somebody puts hands on keyboards. So it's really important. So let's look at the process from a state machine perspective. There's a particular issue in the center, or a user story, or a product backlog item, whatever you tend to call it. And you take a card out of the backlog and it goes forward to conceptual definition. And a person has to do some things to prioritize it up. Then a person has to do some things to define the concept and promote it to UX design. And then a person needs to do the user experience design and then forward it to technical design. And by the way, it's perfectly fine for the same person to cover 2 of the stages. That's no big deal. But define the stages. And then if someone forwards it from conceptual definition to UX design, and the person responsible to execute the UX design really doesn't understand the concept, that's when it gets moved back. So every time you move it forward, there's your filter again. There's your quality check to make sure that it is complete and it's sufficient to be moved forward. Otherwise, we just move it back and try again. Now, some of the work tracking tools have a default board layout that is not 3 statuses: not started, in progress, and then done. That is woefully inadequate. And if you use it, then effectively the not started is your backlog, the in progress is everything else, and then your done is your done. So that will basically, it's giving company management no insight into the status of the work, because it's just, quote, in progress. And they're always going to ask, hey, when's it going to be done? Well, you may be code complete, but it's not in production yet, so it's not done. Or you may not even know what code to write because you don't have a clear understanding of what it's supposed to do in one of those 4 areas. But if you have it labeled in progress, well, guess what? They think that you're working on it, but you might not be working on it. So it's important to flesh out the columns in your project management tool so that anybody that glances at the board can understand where the status is, because I've encountered a lot of development teams that can actually move faster than their product management counterparts. But product management has outlined the project management statuses and effectively has conceptual definition as their column, and then it moves immediately to in development. And so they move it into development, which is basically putting it in the court of the development team. And then they start asking the questions. When are you going to have it done? When are you going to have it done? And then developers try to, because we as developers love to get things done. And we hate for bottlenecks to happen, and we tend to be creative. So innately we'll say, oh, well, I'm not sure how this is supposed to look. So, hey, let's have a conversation and let me as a developer do some user experience design, or let me do some technical design, some test design. And then we spend the majority of our time doing work that is not coding. And then we sometimes look and say, man, I haven't written code all week. What's going on? Well, it's because your process is broken, or your process is not transparent. And so now it's perfectly appropriate for developers to participate in user experience design, but let's recognize that it's user experience design. And the lead engineer or architect needs to be responsible for technical design, but let's recognize that it's technical design. And that we're not actually building a feature yet. We're still trying to figure out what patterns might be appropriate for building that feature. Okay. Same thing with test design. Now, in technical design, that's where it tends to be appropriate to break stories into smaller stories, or at least break stories into tasks, decompose them in some fashion, because in DevOps you want to have consistent flow. So the best size of an item for dispatching to a developer is something where we actually believe that it could get done in one working day, and maybe have 2 working days be an exception. You all know the situation where, for those of you who've done daily stand-up meetings or the daily scrum, where you say, what'd you work on yesterday? What are we going to work on today? You know the situations where you think, man, he said the same thing the day before, or she's been working on that for 3 days. What's going on? Now, you could think, why is that person continuing to work on the same thing? But it's probably because the thing was too large, or there's some unclear user experience design, or or we're in development and we're trying to figure out what pattern to use. We don't quite know how to make this thing happen, and we just call it development. So break things out, and then you'll have a lot more clarity where you have bottlenecks, and then you can solve them. And by the way, these types of charts, I know it has a lot of small text. These types of charts are in my book. So if you request an electronic copy, then you'll get all these in the book. All right, I've already covered this, just to zoom in. All right, let's go to version control. Now, there's some rules of thumb in organizing your version control systems that if you abide by them, all of the DevOps automation products that are out there in the industry will actually work for you, and they'll do a good job. There's so many good products out there, but they're built and tested with some underlying assumptions. And the underlying assumption is that everything that they're working on for a software application is inside one Git repository, and it is the entire Git repository. So what that means is, in order to work with the products that are out there in the industry, we want to have one Git repository dedicated to a single versioned software application. Now, you can have a software system that's decomposed or segmented into many independent software applications. It's perfectly fine. And people who have embraced microservices are decomposing software systems and sprouting new Git repositories all the time. One Git repository has one Visual Studio solution. Now, there's a lot of, I don't mean to jump on an architectural fad, but there's a lot of teams that have gone whole hog into microservices, and then they create a situation for themselves where they have, over 100 little programs running around. You have 100 DevOps pipelines and 100 builds and 100 deployments and all this, and then they realize, oh, maybe that architecture, maybe that wasn't the best name, because I took the word micro seriously, and I really have a microservices. And really, we just didn't like how large our software systems had become. And so we said, oh, I need a little bit more segmentation than what I have now. And so some companies, they went way too far. And of course, like all new fads do when they first come out, people jump on the pendulum and they swing all the way over to an extreme. And then the industry learns from that. And then we kind of come back and we realized, oh, the important thing in this movement, in this microservices movement, was maybe we've made our software systems on average too large, and maybe we should be segmenting them a little bit more. Okay, that's just a little aside. But either way, all the products work really well when you have one application in one Git repository, and then you have your builds operate on all of the code that is in that Git repository. Some of the older version control system technologies created a migration issue just with the English language. For instance, Team Foundation Server had source control system, Visual Source Safe, even Subversion and CVS, those older version control systems. They called the source control server a repository, and you could have the entire company's suite of software systems inside that version control server, and they called what was in the server the repository. And specifically Subversion. Now, you could have multiple repositories, but a lot of people created one repository, and they had and they put a lot of different software systems in them. Now, of course, you could have multiple repositories with both of them, but a lot of people had lots of different source, and it was possible and actually easy to check out and create a working copy of just one path in the repository. Now, distributed version control systems like Git, now Mercurial did give Git a run for its money a little bit, but now kind of Git has won the wars of the new distributed version control systems. They reused the same word repository, but they made it mean a very different thing. They made it mean that which you clone to a working copy. There's no workflow where you pick a path within the repository and clone just that piece to your working copy. And so because they use the same word, but it's different, you just kind of have to keep that in mind. And if you're migrating from Subversion or a centralized version control system, you need to make sure to take every independent piece of software and give it its own Git repository to give yourself a good foundation. The source control system, the source code itself, it is the headwaters of your DevOps pipeline. And so you need to get this right in order for it to flow. All right, let's talk about what a test is, because every single thing that we do in a DevOps pipeline is a test. So in the abstract form, a test has three things. It has setup, it has act or execute, and it has teardown or arrange, act, assert. Or you can set up, execute, teardown. Okay, it has those three things. And so if you were to think of a test as an interface, well, now in DevOps, we have multiple implementations of what this thing is that is a test. The private build is a test. There are things that you do to set up for it, meaning locally, you're going to create the database locally. You're going to, if environment variables are necessary, whatever dependencies are needed on the developer's workstation, maybe you install some chocolatey packages, you're going to do some setup things. Then you execute or act. You do a compilation. You translate text source code to executable format, and then you do some asserts, which you're going to run your unit test suite, your integration test suite, maybe some static analysis. Then same thing, integration build. Integration build is a test. You're going to do some things to set up, then you're going to execute, and then you do some asserts. All right. The build steps of your private build and your integration build have a lot of overlap because your integration build effectively uses the private build script, but it runs it on a team shared build server. So it's the same script, and then if it passes, well, then you go and maybe do a few extra steps, including packaging it up as a release candidate, all right? And we'll talk about how deployments are a implementation of a test as well. But let's talk about what happens after the integration build. We're going to do packaging. Now, probably among other types of software, you probably have an application that has a SQL Server database, a ASP.NET web application of some sort. Maybe it's ASP.NET Blazor, maybe it's ASP.NET MVC, maybe it's Web API, some sort of flavor of web application. And maybe it also has an offline job. Well, each one of those three have to be deployed intentionally. And so if it has to be deployed, it has to be packaged in a manner suitable for deployment. And in the .NET ecosystem, that package format is the Nuget package. Now, a Nuget package is just a zip file with a different extension, and it has a manifest and it has a name and a version. So you could literally take the nupkek file, which is the Nuget package extension, you could rename it to .zip, and then you could extract it right there because it literally is a zip file, okay? So the Nuget package is your perfect format for packaging release candidate components. And so if you have this web application offline job SQL Server database, then your release candidate is going to end up with 3 Nuget packages, all with the same application name, then component name, and then version number. That tends to be how they're named. And you're going to push that into Azure Artifacts, which is part of Azure DevOps Services. Now, you could store it anywhere, but that's the perfect service. It's got a built-in NuGet server right there, and Octopus Deploy has a NuGet server in it as well. Or you could just drop them on disk somewhere. But Azure Artifacts is just so good and so easy, and you already got it. Also, your acceptance tests are going to need to be packaged up as a release candidate with the same version, because your full system acceptance tests run on a fully deployed instance of that release candidate. So we need to make sure that we deploy the right version of the acceptance tests so that they run against the proper version of the application. Now, as we deploy downstream to at least a minimum of 3 environments, because you need at least one of each of the 3 key types, we want to make sure that we deploy the same release candidate. And when I say the release candidate, I mean like Palermo co-application version 1.0.500. All right, we're going to deploy that version of the application. Now, we all know it's a set of 4 NuGet packages that make up the release candidate, and they're each of them need to be deployed. But I want to stress that we do not we do not go back to text-based source code and do a compilation process again and create a different release candidate structure to go to UAT or to go production. We literally use the same set of NuGet packages for every environment. That way, our quality checks become cumulative. By the time we deploy to production, we are deploying everything and only that which is inside the NuGet packages that make up the release candidate that has been tested on the UAT environment and the TDD environment. Okay. I have heard some people say, oh, I need to build to UAT, or I need to branch the source code for UAT or branch to production and then build to production. That is not a DevOps pipeline. That is a different process. That's not a pipeline. So in a pipeline, it is one way through, and you push things through the same process all the way through, and you arrange the environments in a sequential order so that the same release candidate goes from environment to environment to environment and then ends up in production. And of course, in Azure pipelines, it's going to kind of look like this. This is the minimum configuration for Azure pipelines. Notice the 3 environments are in a sequence. The TDD environment has the little beaker, so you can see 100% of the full system tests succeeded on that environment, and that it came from the integration build, and then UAT succeeded. There's really the only test that's run there is the health check, which we'll talk about later. And then in production, we often have our approve button where somebody in product management can click on the approve button and it's sitting ready to go to production when needed. Now let's come back to our test interface. The test automation deployment, that is effectively a test. There is setup that we do. There is execution of actually deploying it and starting it up. And then there are assertions. We run the acceptance test suite. For the manual test environment, UAT, we do some setup. Now some different. We don't completely create the environment from scratch like we sometimes do in a test automation environment, but we do setup. We do configuration. We deploy the files, which is our execution or act step, and then our assert is both a built-in health check to make sure that it deployed and started up, but then also manual testing. Manual testing is an assert. We make sure that things went well. And then in production, we do the same thing, but we have a few more asserts and some ongoing asserts. Smoke tests, taking an IT management product that can ping a URL every now and then, and maybe we make that URL do some internal tests. Tracer bullets, where we're actually constantly running fake transactions through the system, or telemetry that's pushed out to Azure Application Insights. All of those things are ongoing asserts in a production environment. So everything we do in a DevOps pipeline effectively is a test and has those 3 basic steps of setting up or getting ready for it, then actually doing it, and then checking to make sure things happened correctly. If we do something, we do the act, but we don't have asserts, then that's just like pushing water down a pipe and not having any check for water quality. And then when you open up your faucet in the kitchen sink, maybe it's brown, maybe it has E. coli in it. We just don't know because we didn't check. Okay, so every time we push code, we push a change down our pipeline, we need to have a corresponding check, which effectively are the asserts. Okay, let's look at how Azure pipelines might look for a TDD environment deployment. And your UAT and production deployment are going to look similar. They're just not going to run the acceptance tests. Now, I intentionally am showing you the designer view of this just because it's easier to follow, and the YAML experience in Azure pipelines was started and it was deployed, but then the GitHub acquisition took place, and a lot of leaders kind of left the Azure DevOps team and went over to GitHub. And the YAML implementation, they've kind of tweaked a few things, but it's still not complete in my opinion. And so I still haven't been able to recommend to my clients to go whole hog into YAML. Now, if you've done it for yourself and you like it and you prefer it, that's fantastic. I have no issue with it. But for people who are getting started, I showed them this first just because you can visually see what's going on. But there's a pattern that emerges. We want to tell application insights that we're starting the deployment, so we give an annotation. Then we want to obtain a package, and we'll start with the database. We want to do a little bit of setup, which is create the test database with an ARM template. And then we want to actually use our database migration tool to create the database schema. That's our PowerShell step. So we get the package, we do some environment setup, and then we deploy. Now, same thing with the UI package, which is our web application. We get the package, we do some environment configuration, and then we deploy, which is UI deploy, and then start the website and execute self-health check is basically our first assert. We start the website, and if that checks out, great. We still don't know if the website can even do anything or if the website can talk to the database. So we execute the self-health check. This is calling an endpoint, which actually runs some code that does a quick query to the database. And if I messed up the connection string or if the database is not online, it'll fail. So we do not want our deployment automation reporting success unless it actually succeeded. So we need to call into the application and ask the application, hey, application, are you healthy? And then if that passes, then we know that it deployed, it started up, it's reporting back health. And now we can do the same thing for our acceptance test suite. We can download the package, we can do a little bit of environment setup, configuration, and then run this test suite. And then for our TDD environment, it's effectively get rid of the environment. And then we can have a TDD environment for pennies just because it's not up and running for very much of the month. So now let's kind of review from source code all the way to when we would be ready for a pull request, because we can't, in this process, we don't create a pull request to take what we did on our feature branch and push it into the master branch until our pull request has been accepted. And we don't even submit a pull request unless we know that what we did deploys properly and still works properly. And so on our branch, we go all the way through the TDD environment. So this really helps with defect removal. Capers-Jones, probably the most prolific aggregator of research in the software industry, has come across 3 quality control techniques. He calls them defect removal methods that when you combine them together, they reliably, for the teams that use them, reliably produce really, really high quality, which he calls defect removal efficiency. meaning removing 99% of all possible defects before they go to production. And those techniques are testing, static analysis, and formal inspections. Now, the Agile movement, specifically extreme programming, gave us the automated testing methodologies. And specifically, I recommend a minimum of 3 levels of test automation: the unit tests, the component level integration tests, where deployed modules talk, or deployed processes talk to the next deployed process, meaning web application to SQL Server. That would be an integration test. And then full system acceptance tests that are run against a fully deployed instance of the application. So that's our testing. Static analysis is just those command line static analyzers. You have Roslyn analyzers, you have CSS, or you have JavaScript linting, you have CSS analyzers, you have HTML. Every type of code has a command line analyzer for it. And so it's just a matter of putting those in and then, of course, tweaking the rule sets a bit, because it's going to find problems. I mean, I didn't know that in JavaScript, in order to get the equivalent of C#'s double equal for an if statement, in JavaScript, you had to use 3 equal signs. I had no idea. C#'s double equal is functionally equivalent to JavaScript's triple equal. But I actually found out by running a JavaScript analyzer, which kind of threw a bunch of warnings because I was using a whole bunch of double equals all over the place. And I wasn't aware. That wasn't my intent. So we've got that going. So let's fast forward. We got the CI build kind of down in the build server, and this is an activity diagram, so you know what's happening where. Then in the TDD environment, we do our deployment. We do our automated acceptance tests. Once that completes, then we can create our pull request, and then somebody from our team can inspect our pull request according to the team's agreed upon checklist. The pull request is the perfect spot for implementing a formal inspection as defined by Capers-Jones. And all it takes to make something a formal inspection is to make it the same way every time. And a checklist does that. So just as a team, create the checklist. What are the things that you're going to check for? And go through every piece of the checklist every time. And when the reviewer clicks the approve button, or the complete button, that means that they, on their honor, on their reputation, are saying that the changes represented in this pull request comply with every bullet of this team's checklist. And boom, you got a formal inspection. It's brilliant. All right, so let's kind of review the different activities that we do down the deployment part of our DevOps pipeline. TDD, we do a bunch of stuff, UAT, prod. It's very important that we don't do anything in production that we haven't practiced many, many times before. We don't do anything new in production. That's why, for instance, state-based database deployment tools don't work very well in a DevOps environment. DACPack or Redgate SQL Source Control don't work very well in a DevOps environment because they look at the downstream database that they're about to deploy to, and then on the spot decide what SQL queries, what alter statements to generate on the fly to execute against your production database. Whereas more modern tools like DBUp or Flyway or Redgate SQL Source the new deployment tool, I'm blanking for some reason. Those tools operate in a migrations based approach where everything is checked into source control. You see the SQL file that is going to be executed against all of the environments. And so that literal script has been tested on the TDD environment, the UAT environment, before it goes to production. All right. Let's zoom in a little bit to some of the parts of Azure pipelines that you will really want to take advantage of when you have a pipeline with this structure. This is a screen grab of the execution of the full system tests in the TDD environment. And so you can see some of the acceptance tests on the left-hand side listed out. Now, this is just a sample. It shows 6 tests. But then on the right-hand side, there's attachments. Let's just zoom in a little bit on that. And we can see the attachments are screenshots of a web form, basically the contents of a browser without the browser frame. And the key here is when we are running full system acceptance tests, every step that our test makes, just go ahead and do a screen grab right then and there, and then attach those JPEG files or PNG files, whatever format they are, to your test as attachments, and then Azure Pipelines will save all of those attachments in the test runs, because at some point in time, the test is going to fail, and you will probably be able to see what the screen looked like and know immediately where to start diagnosing. But if you don't know, all you know is, oh, the test failed. Then you have to go and execute the test again just to get that intelligence. So it really streamlines things. Disk space is cheap. You can purge old builds. If you need to. I've never needed to. And just literally every step you take, do a screenshot, and you'll thank me later. All right, let's go into how to know what your application is doing in production, because every time we make a change to the software, we're just operating on a hypothesis. We think that making this change to the software is going to make things better or help us achieve our business goals. But we don't actually know. We're making assumptions. And I believe it was the 2018 State of DevOps report that analyzed teams that were using the Scrum methodology and had implemented a Scrum product owner. And they identified, it was really striking, that with the product owner making decisions of what features to prioritize and what things to change, the product owner got it right about a third of the time, where about a third of the time that change was beneficial to the organization. About a third of the time they made that change, it really didn't make a difference. And another third of the time they made the change and it actually hurt what they were trying to accomplish, and they had to hurry up and back it out. So the concept of Scrum's all-knowing product owner that is the arbiter of what is useful is kind of debunked. And so we realized that when we prioritize something and when we decide to change the software in a certain manner, it's just a hypothesis. And we won't actually know until we measure how it impacts our users in a production environment. So it's important that we have the telemetry so that we know what impact it's having and if we like it or not. Because if we don't like it, we need to back it out. And this is where you want to take your logging, which Microsoft includes, iLogger, and you could just output statements all over the place. A lot of people put logs in their software, and that's great, but that's only part of what you need. You need to elevate your logs to be telemetry so that they're quantifiable, so that you can graph trends. You can search logs, and as a human, you can follow along in the logs and kind of guess at what's happening, but you can't quantify the behavior from just the logs. And so how do we do that? We need to add metrics and events to the information that we emit from the application as people are using it. And let's talk about that. So as each piece of our application is running in its appropriate environment, this information needs to be emitted to a single place, and that is Azure Application Insights. Now, truthfully, there's plenty of good APM tools on the market. APM stands for Application Performance Management or monitoring. And you got New Relic, you've got Stackify, you've got Splunk. There's a lot of good tools out there. You got Datadog, and the one built into Azure is called Application Insights. I actually really like Application Insights. It's pretty darn easy. But again, I will admit there's a lot of great products, and that's awesome. We have a really, really good ecosystem. But if I go back, logs are just informational statements. Metrics are numbers, and events are names. So in your different software systems, you've probably implemented a data warehouse for some of the people in your company or some of your customers. You've probably implemented a analytics data store or some reports that showed a line graph or some type of bar chart. Well, in order to do that, you needed to have a data structure that used the core building blocks of the Kimball method of data warehousing, which is the fact table. If you've never heard of a fact table, then I would encourage you to research the Kimball method of data warehousing, which is kind of one of the forefathers of analytical databases, which kind of make up data warehouses. And we do it for our customers, but when we elevate our logs to telemetry, we effectively create these fact tables for ourselves in our monitoring tools, because every time an event happens, we record a record and we attach to it numbers, which are metrics. So if you think of it as a data store, every time maybe one of your users presses a button to initiate a certain type of transaction, well, guess what? That's an event. A user did something, and we need to record that this event is happening. And this user on this time of day is doing this. And it took so many milliseconds to complete, or whatever metric is appropriate, and we store it in our database. And events are appropriate for filtering and grouping by, because they're typically strings, the names of them. Metrics are typically numbers. They are appropriate for doing average, sum, min, max, things like that, aggregate functions. So you put them together, and now you have the ability to create line graphs of trends and bar charts out of the behavior of your users. And that's really powerful. Application Insights, it gives you a lot of logging, a lot of technical logging for free. For instance, right here, it knows Entity Framework and it knows SQL Server, so it can capture queries for free. But by also capturing custom events with metrics, we can produce graphs like this. Now, this is from a car auction application, and we can see over this time period, the general trend was increasing usage, but we can also see some seasonality in it. And you see the drop down, only 5 events are selected. Because we are emitting events attached with metrics, we can choose which events we want to investigate in, and they're just all there. Now, you look at them, and I guarantee you will find those exact names as class names in the code base. So it's really easy to track back. And then the green dots at the top of this graph are from annotating when we deployed to the production environment. And so we can see how we can see how the application is behaving and how our users are behaving, corresponding with when we deployed. And if your graphs start to go the wrong way right after one of these green check marks, then maybe you didn't make as good of an impact as you could have, and you roll it back. Or it's confirmation that, okay, we deployed and then the graph went in the direction we wanted to. And then if you click on one of those green check boxes, it'll pop up everything about that deployment, including a link that you can click to go right back to Azure Pipelines where that release candidate was deployed. So you've got traceability all the way through if you hook it up in this manner, and it's really cool. All right. So I'll kind of look at the chat for questions, but this is the last slide. Remember, here's my email address at the bottom if you want a copy of the book. But let's go over to the chat if we have any questions. I don't see any, but John, maybe I'm not looking in the right area.
Yeah, I haven't seen any pop up.
Okay.
So,
So
yeah,
that's
that
a
was good.
lot of me talking, but if there's any questions, I'm happy to answer them or clarify anything.
Yeah, you shared a pretty big walkthrough. So I'm sure a lot of people are just absorbing right now.
Yeah, yeah. It is. It's a lot. It's a lot to put together. And we have great products out there. And I will say, Azure DevOps, you already have it. It's the native tool for the Microsoft ecosystem. You start with it, but you expect to add things to it. No single product is going to do every bit of this. You're going to have a mix. So don't feel bad if it's like, no, I thought we were using Azure DevOps for this. Well, okay, it's kind of at your hub, it's your main orchestrator, but you're going to have in-unit, you're going to have Selenium, you're going to have static analyzers besides the ones that are Roslyn based. And as your deployments get more complex, you'll probably graduate to Octopus Deploy and integrate Octopus Deploy into Azure pipelines for your more complicated deployment scenarios. If Application Insights works fine, that's great. Or you might integrate, Datadog, for example. So don't feel bad if you start to hit a wall with something and you say, hey, maybe I need to integrate another product. That's perfectly normal. You'll have to do that.
Mm-hmm. I'm just looking at some of the comments coming in. One question I have, like you mentioned with YAML and having the graphic experience. I also have come across, I think it's called Pulumi. Is that right?
Yeah, that's one of the commercial tools. Yep. Mm-hmm.
Yeah. How do you, because that kind of allows like a .NET developer, C# developer to kind of stay in their tooling, their stack, almost like what Blazor does for the, for web-based development.
Sure.
How do you, what are your opinions of those kinds of like, do you see more of that? Like things kind of falling in within your tool set, and used in kind of unique ways. Like here, Pulumi is like a replacement, basically, from what I understand, for what you do with YAML. I believe I'm not.
I actually interviewed the founder and CEO of Pulumi on the Azure DevOps podcast a while back.
Oh, okay.
So you can find that in the archives. I would put Pulumi in the same category as Terraform,
yeah.
and Azure ARM templates. So YAML is effectively a scripting language or scripting format. It's a
Right.
set of steps.
Right. And I was more so thinking of Terraform and for what that produces.
Yeah, I think you're right. Pulumi is a direct competitor to Terraform, direct competitor to Azure ARM templates. I am still waiting. If I was in that space, I would love to create this architecture, but I am still waiting for environment migrations. Right now, cloud environments are at the same stage that SQL Server databases were about 14 years ago, when DAC was first really coming about, when Redgate SQL source control was coming about, where we're going to look at the target environment and then on the fly, we're going to generate scripts with what to do. Well, Pulumi and Azure ARM templates, they do that. You write your scripts with how you want the environment to be, but if you point that at environment A versus environment B, it's going to do different things because it's going to inspect the target environment and decide on the fly what to do. That right off the bat doesn't give any chance for quality control, so that you're deterministic. Now, probably 80% of the time, that's just fine, just like it was with SQL Server databases. But the remaining 20% of the time are sufficiently annoying and sufficiently dangerous for the stability of your system and the time that it takes to recover from that 20%, that it stops being useful. So I know, just because it's a broken record now. We've already been, history repeats itself. We will get to the point, the vendors will figure out that for cloud environments, we need an environment migrations pattern the same way that the database deployment world has discovered that.
Yeah, that makes sense. I agree. Well, if there are no more questions, I think we could wrap it up here.
Awesome.
All right. Well, thank you, Jeffrey. I really appreciate your time and a walkthrough on all that. And yeah, I can see that some of our other attendees also expressed the same.
Thank you, Matthew. Thank you, Landis, and appreciate it.
All right. Well, thanks, everyone. I'm going to go ahead and stop the recording, and we'll see you next month.
All right. Have a great evening.
All right. Thanks, everyone.
All right, bye.
All right. Bye-bye.